Alright, grade 11, so here's just a quick revision of your grade 10 trigonometry. So if we look here, we have a right angle triangle with sides 3, 4 and a hypotenuse of 5. I've marked an angle theta, could be marked anything, but I've just chosen theta. And we're going to look at how we'd find sine theta, cos theta, tan theta. Now remember, sine theta in a right angle triangle is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. The angle that they ask you for with the sine, cos, or tan, it's your starting point. So for sine theta, you're going opposite from theta over the hypotenuse. Then when you're working with cos, you're going adjacent over hypotenuse from theta. And for tan, it's going to be opposite over adjacent. Now, if we had called this angle up here, let's say x, and you did sine x, you go opposite over hypotenuse from that direction. So you look at what the angle is that's been given to you with the sine, cos, or tan, and that tells you where to start with your ratios. If you're asked to solve for theta, so that was just asking for the ratio of the sides. If you're asked to solve for theta, you would go sine theta equals 4 over 5, and to get theta by itself, you have to say in your calculator sine negative 1 of 4 over 5. Now in grade 11, we don't expect you to write the sine negative 1 anymore. You can go straight to saying shift sign on your calculator of 4 over 5, and that gives you theta is 53,13 degrees to 2 decimal places. So you can go straight from that step to that step. Now in grade 11, we are going to be adding a little bit more to it, but that's the basic idea. You do the same for cos and for tan. Alright, now moving on to our special angles. Now most of the time, a lot of you use your calculators for it. Please just don't write the decimal down. Some of you use the triangle version from last year of how to find the special angles. This is just an alternative method for those of you who like studying things off by heart. You can start by going 0, 1, 2, 3, 4, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. Then you divide by 4 for all of them. And then for the last one, it's divided by 4, 3, 2, 1, 0. That 0 on the end there will get us the undefined for tan of 90, which is its asymptote on a graph. So then you take the answer and you simplify it and you square root it. So 0 divided by 4 is 0, square rooted is 0. So the sine of 0 degrees is 0. Then simplify this 1 over 4, that's 1 over 4, so take the square root of it is a half. We can simplify this to 1 over 4. Correct myself, 1 over 2. So that ends up being 1 over root 2. Now your calculator will tell you it's root 2 over 2. That's just the rationalized form of it. It's the same thing. It has the same value. Here we can't simplify, so it ends up being root 3 over 2. And then 4 divided by 4 is 1, which ends up being, the root of 1 is 1. And then just filling in all the rest, that gets you your special angles. Again, your calculator will give you the rationalized form, so it won't give you any answers with the root signs at the bottom. It does a little bit of a special kind of maths trick that can get you to it, but you can use either the rationalized or the non-rationalized form. It does not make a difference. So now we go into the Pythagoras type questions from last year. Now, if you look at your notes that you've been given, there was a grade 10 revision note, and this example was there. So you're given little clues here. So the first clue is when they tell you if sine, cos, tan is related to a value, then you've got to do something with it. And they give you another clue as to which quadrant you're going to be working in your Cartesian plane. So let's have a look at 13 sine theta equals negative 5. So if I get sine theta by itself, it ends up being negative 5 over 13. Now, hopefully you remember from last year that we had a little diagram, very basic, that told you what was going to be positive where. So all sine, cos, and tan are positive in this first quadrant. Sine is only positive here, tan, cos. So we need to find, this clue says, where is sine negative? So sine is negative in tan and cos's quadrant. Then they give you another hint, another clue, that says you have to work between 90 and 270. So there's 0, there's 90, there's 180, there's 270. So we've got to work somewhere between there and there. Now where you have the double tick, that's where you're going to be drawing your triangle for Pythagoras. Now they told you that sine theta is negative 5 over 13. So that means opposite over hypotenuse for sine. The hypotenuse is always positive. So it means that our opposite from this angle, so this whole thing is considered theta, but from the inside there, we go opposite, negative 5, 13 is the hypotenuse. Now it makes sense that negative 5 is there because we are under the x-axis for y, which means y is negative. Then we will have to work out what the x value is here. Now we use Pythagoras for that. So x squared plus y squared equals r squared. Now that's your Pythagoras. So x squared we don't know, y squared is negative 5 all squared, and your r squared is 13 squared. So if we solve quickly here, we end up with x squared equals 144, and then when we square root both sides, x is plus minus 12. So now check on your Cartesian plane. X must be negative because we're sitting on the scale. So that means x is negative 12. So you can go fill that in on your diagram. So then now we've got to try and work out what cos theta plus sine theta is. Now cos theta plus sine theta is the same as saying adjacent over hypotenuse plus opposite over hypotenuse. So we don't want to solve for theta here. They're not asking us to use our shift button on our calculator. We're just filling in from the triangle. So adjacent from that corner of the triangle is going to be negative 12 over the hypotenuse, and that negative 5 over the hypotenuse, which gets us negative 17 over 13. Now they can ask you to do anything with tan theta, cos squared theta. You take whatever you got from the diagram and you square it or you add it, whatever they're telling you to do with it. As long as it's got a theta, and that's what we have on our diagram, a big theta there, then you can use this triangle. Right, that is pretty much grade 10 trig summed up. We move on to grade 11 trig.